Screen is visible for you?
Yes, sir.
Right. Yes, sir. This what happened. We'll see what the preparation, how generally methanol is prepared, isn't it? What are the methods generally taken? The preparation of what? Methanol actually. So methanol is also called what? Wood spirit, isn't it? This is called what? Wood spirit, prepared from the wood actually. Wood spirit we can also call nothing but called methanol. Methanol means CH3OH. Methanol, CH3OH, methanol, also called wood spirit. It can be prepared by the wood. That is the reason called wood spirit also. Now, how it prepared? By destructive distillation of wood. Distillation means what actually? Heating here. Destructive distillation. Heating repeatedly what happened? You are going to get this methanol actually. Now, what are the reactions involving in this one? Carbon monoxide react with hydrogen in presence of chromium oxide and zinc oxide at high temperatures. That is what 570, 360. That means around what happened? Up to 300 degrees Celsius, 250 to 300, sorry, 200 to 300 degrees Celsius, isn't it? And 200 to 300 pressure actually. Easy to remember this values. 200 to 300 pressure or 200 to, isn't it? Sorry, 300 to 400, sorry. 300 to 400 degrees Celsius or 200 to 300 atmosphere pressure. So these are the catalysts which are very, very important. One is chromium oxide, other is what? Zinc oxide. Chromium oxide, zinc oxides are the catalyst we are using, and the reactants are what? Carbon monoxide and hydrogen here. So we are going to get here methanol. So this is very, very important reaction. Remember this reaction. Important reaction, carbon monoxide on reacting with hydrogen in presence of chromium oxide and zinc oxide, what 573 to 673 Kelvin temperature and 200. That means high pressure and high temperature, isn't it? At high temperature and high pressure, methanol, methyl alcohol, isn't it? Methyl alcohol is what? Poisonous, isn't it? Compared to ethanol, what happened? Methanol is what? Highly poisonous. Why? Because methanol on undergoing oxidation, it will form formic acid. That is what very dangerous. That is the reason it's a poisonous. So these are the something what happen uses here. It can be used in the paints and varnishes here. Ethanol is something prepared fermentation process. Ethanol is not poisonous. It is prepared in fermentation process. Fermentation process means what will take here actually? Sugar will take. This is a sugar actually from sugar canes. Okay, sugar from sugar canes. On doing hydrolysis, invertase is a enzyme actually. Invertase is a biocatalyst. I can write simply what happened? Biocatalyst, nothing but an enzyme, biocatalyst. In presence of invertase, undergo hydrolysis to give 1 mole of glucose and 1 mole of actually what here? Fructose actually, isn't it? 1 mole of fructose, 1 mole of glucose you are going to get. And after that, in this case, we'll take what? Glucose again. Okay, in this case, again, we'll take glucose and doing what? Again, reaction with what? Biocatalyst, same zymase in this case. Biocatalyst, zymase. You are going to get 2 moles of ethyl alcohol plus carbon dioxide. We are going to get, isn't it? So this is called what? Fermentation process. Fermentation means what? Cutting into simple units actually. So the macromolecule like sugar is converted into what here? Ethyl. What are the biocatalysts we are using in this vein? What are the enzymes we are using? One is invertase for what? Conversion of sugar into what? Or sucrose. Sugar is nothing but here what? Sucrose. Okay. Conversion of sucrose into glucose plus fructose in the presence of invertase. Conversion of glucose into what here? Ethyl alcohol in presence of zymase is called what? Fermentation process here. These are the boiling points, isn't it? Nobody asked the boiling points here. Generally, ethyl alcohol is used as a solvent. Many number of times you are using polar solvent. It is a polar solvent have taken here, used in the paint industries for the making a solvent, isn't it? So paint industry, what happened? The solvent we use for alcohols. Next. Now, I think we have discussed this topic in the last class. Anybody is possible? 1 bromopentane by reacting with aqueous NaOH. What will be the product? Is it possible for you? 1 bromopentane. 1 bromopentane on reacting with aqueous NaOH. What is the product? Tell me, what is the product here? Aqueous Na. When you take aqueous KOH or aqueous NaOH, what happens? Aqueous KOH, what happens? In the last chapter, we discussed this one. Alkyl halides, SN1 reaction. Anybody? What happens here? In the place of bromine, what we get here? Are you there?
1 pentanol.
In the place of this one, what we get here? OH. So
OH.
what? 1 pentanol. Isn't it? 1 pentanol we are going to get here. We have discussed this one. Hydration of ethene produced. Tell me, in the last class only we discussed this one. Hydration of ethene. What is the name you are going to get here?
Ethanol.
CH2 double CH2 is called ethene. On doing hydration in presence of what? Acid plus water. So this is symmetrical molecule. Add here hydrogen, add here OH. Unsymmetrical, which rule you have to follow if it is unsymmetrical alkene?
Markovnikov's rule.
Markovnikov rule. So what is the name here? Ethanol, isn't it? These are simple things. You have to remember compulsory. Now 2-methyl-butene produced, they are asking. 2-methyl-butene, आप कैसे लिखते हैं आप 2-methyl-butene? But first of all, you have to select what root word. So what is the root word in this case? But. But is the root word. But means how many carbons, beta?
4.
4 carbons. Have to write. Now write the numbering in. Whenever you write the structure, no, you can give numbering as your wish. Give numbering in this like that. You can give from right hand side or left hand side. Now put here on second carbon methyl. Second carbon is having methyl. Next, 2-ene means double bond present on second carbon. So double bond is present on the second carbon like this. After that, put the hydrogens remaining. 3 hydrogens. Here how many? Only 1 hydrogen is required. Here no hydrogens are required because 4 bonds are there. No need actually. Only 1 bond is there. Put here 3 hydrogens. Now this is the structure of what? 2-methyl, 2-butene, right? Now here we are doing what? Hydration, addition of water in presence of H plus. Now you have to add water and that means OH plus and OH minus. Now where we have to add H plus and OH minus? Second OH minus will be added on second carbon or third carbon according to Markovnikov rule.
Third carbon.
Of rule, OH minus will be added on second, third carbon. 2 or 3?
Third carbon.
Third. Second carbon.
What is Markovnikov rule? The negative part attacks the double bond carbon which is having less number of hydrogens or no hydrogens. Now which is having what? Less or no hydrogens? Second. OH must be added on second carbon and the H plus will be added where on the third carbon. So you are going to get the structure like CH3, CH3, isn't it? CH3. Now here you are going to get the OH and here you are going to get the hydrogen, that is I am writing CH2. Now definitely the numbering must be done from here only from here only. Because if you done here what happen? We get 2. But if you done from here what happen? We get 3 here. So it will be 2-methyl butane 2-ol. So answer will be what here? 2-methyl butane 2-ol. So which option correct here? Third option. 2-methyl butane 2-ol will be the right answer. In this way, we will get the questions in examination. Concept is very, very crystal clear. It is according to Markovnikov rule. So if we know the writing the structure, if we know the nomenclature only, we can do the problem. That is the reason frequently I am saying what nomenclatures. Oh, in any chapter I am explaining the nomenclature. This is the reason actually. Now second preparation, let me see. Very, very important in conversions. Very important one. Hydroboration of oxidation of alkenes. Hydroboration of oxidation of alkenes here. Now let me see what is it. Here. See now here. Now here also this method is useful for the preparation of alcohol because we are discussing the preparation of alcohols. That is the reason we discuss only this type of reagents only. First method is what? Hydration. Nothing but addition of water in presence of acid. Second method we are discussing now. What is that? Hydroboration. hydroboration, oxidation of alkenes. Now, in this case, what happens if you observe what happens? Let me see this one. Now, this one is the propane. Leave it the 6 mole. Just leave it. We'll discuss this one 6 later actually. Okay. Propane it is here. This propane on reacting with borane or diborane. Generally, we'll take borane in the mechanism, but when you write what happened, diborane. This is called what? Diborane. This is called what? Now you got this intermediate. This is the intermediate we are going to get, tripropyl borane. And after that, what happened? You are going to get the alcohol. This will convert into what actually? Alcohol. Isn't it? This is converting into alcohol. Isn't it? N-propyl alcohol. Here, very important thing, if I observe what happened, you are getting in anti-Markovnikov product. In the previous case, what type of product you got here? Markovnikov product. Now you are getting what? Anti-Markovnikov product. So I am writing some equations here. CH3, CH, double bond, CH2. Here, H2O in presence of acid, H plus. This can also write down like this also. Dilute H2SO4 also they write here. Okay, both reagents are same. Dilute H2SO4 is nothing but acid in presence of water only. Understood here? Everyone. Dilute H2SO4, H2O in presence of H plus. All these are called hydration reactions. So what are the reagents generally used for hydration? H plus in presence of water or dilute H2SO4. Both will do hydration. Now tell me, what is the major product here? All of you. What is the major product you are going to get? Tell me. Do fast. What is the major product here? Are you there? Hello. Good morning. Good evening. Good night.
Yes, sir.
Tell me the product name. Major product will be there here. What? Major product. Which rule you have to follow? Markovnikov or anti-Markovnikov you have to follow in hydration?
Markovnikov rule.
Markovnikov rule. Now tell me the product better. Markovnikov rule. So well, tell me the product. The negative part attacks which carbon? CH or double bond CH2?
Propane to all.
Remaining are getting confusion here. Very confusion you are getting what? Very much confusion. Very simple. OH minus attacks on which carbon? Double bond carbon having less number of hydrogens. This is having what? More hydrogens. This is having what? Less hydrogens. Only you have to see the double bond carbons here. So the OH minus attacks were on the this one. You are getting, this is the major product. What is that one? Propane to ol or 2-propanol. But if I do something like this, CH3, just now we seen this one, CH double bond CH2 on hydroboration, on doing what method here? Hydroboration. Hydroboration followed by oxidation. Hydroboration. Which reagent you have taken? B2S6 followed by what? Oxidation. Followed by oxidation. Which reagent you are taking? NaOH in presence of H2O2. Now what product you are getting here? Anti-Markovnikov product here. Anti-Markovnikov product. All of you write this one, because after that I will rough this one. It is not available for this one. So write down this one. Which product we are going to get here? Anti-Markovnikov product here. This one. This will be the major here. Now the name of this one will be what here? Propan-1-ol. The name of this one is called propan-1-ol. This is the major product. So if you want what? Markovnikov product, you get that one, hydration. If you want anti-Markovnikov product, which method you have to follow? Hydroboration followed by oxidation. Very simple. Most of the cases what happen? We get the primary alcohols here. Okay. Most of the case we get here primary alcohol. Most of the case we get secondary and tertiary. This is not secondary. This is not tertiary. This is secondary. But in the case what happened? We get what? In this case secondary and or tertiary alcohols we get. For getting tertiary secondary alcohols, generally we go for what? Which method? Markovnikov product or hydration. To get primary alcohol, which method we have to follow here? Hydroboration we have to follow. Understand all are the differences here. If you write like this, we'll get number of questions we can generate from this one. Number of questions here. Thing is that Marconic product here. It is a Marconic product. Here it is anti-Marconic product. Here the major will be what? Secondary or tertiary we get here. Here major will be what here? Primary we get here. What are the reagents we are taking? B2S6 and NaOH in presence of what? Hydrogen peroxide. Here the reagent is what? Dilute H2S. Take a snapshot and later also you can take this one. Take all of you a snapshot this one. After the class also we can write this one in your notebook. So in your notebook it will be should be there actually. In this way only you can easily identify the products one. Very, very important for the conversions here. Most of the case will get conversions here. Understood here all of you? Any doubts regarding these two reactions? Any doubts you're having?
No, sir.
Very good. So this is about what? Preparation of primary, secondary, tertiary alcohols. Primary from the hydroboration followed by oxidation. Reagent आपको याद रखना है. So base, any base, you can take even KOH also. Base in presence of hydrogen peroxide. Okay, then only it will be easy for you. Now you observe the only primary alcohol that can be prepared by hydration of alkene is what? This method. Which method? Hydroboration method, isn't it? So what will be the answer? The only primary alcohol that can be prepared by the hydration of alcohol. This is the different type. Ethane generally. For example, if they ask like CH2 double bond CH2, okay. Now, if you do with what? Dilute H2SO4. If you do with what? Hydroboration. B2S6 and followed by what? Sodium hydroxide in presence of H2O2. First reagent, second reagent. Now in this case and in this case, both the case you get same product or different product? Tell me. In both the case.
Same product.
Same product. That means when you get symmetrical alkenes, you will get definitely what happened? Same product only. The product always will be same for what? Symmetrical alkenes. Here there is no anti-Marconic, Marconic here. No Marconic here. Isn't it? Only what we are getting here? One product here. So you can take any reagent, dilute H2 B2S6. That's the question actually they are asking here, isn't it? So what's the product you are going to get in this case? The name of the product will be what here? CH3 CH2OH. This is a primary alcohol. So even with hydration also we get here primary. But most of the cases, for most of the unsymmetrical alkenes, isn't it? You may get either secondary alcohol or tertiary alcohol, isn't it? You may get secondary or tertiary alcohol. In which case, unsymmetrical alkenes, when they do react with what? Dilute H2SO4. Again, unsymmetrical alkenes, when they do reaction with hydroboration followed by oxidation with sodium hydroxide, hydrogen peroxide, you will get most of the cases will be primary alcohols only, isn't it? So you have to do some exercise by taking different types of alkenes. There are number of alkenes are there. 2-methyl-butene, 2,2-dimethyl-butene, isn't it? 2,3-dimethyl-butene or pentene, 1-pentene, 2-pentene, isn't it? Like that, you take number of examples and do the hydration and do the hydroboration also. If you get any doubts regarding Marconic, and you can pose the questions also like that. So if you do practice like that, what happens? It will be easy for conversions actually. Okay. Don't by heart, whatever I explain, what happened, don't by heart that one. Whatever I'm explaining, no, reading that one time, that is not correct. That is for what? Theory topics. That is for something bio topics like that, what happened, it will work out. Theory topics like that, it will work out. English, bio, it will work out. Why? Because there were theory topics. You can read that one. But here what happened? You need to practice here. So this reagent you have to do number of times. Next, if you see what happened, hydroboration oxidation reaction follows. Which will tell me better?
Anti-Marconic.
ऐसा आपको याद रखना है. ऐसा रिपीटेडली आपको याद रख ले तो अच्छा लगेगा ना. Tell me the answer for this one. Isobutylene आपको लिखना है भाई, ऐसा दे देगा. Isobutylene only they will give you actually. Now what is the isobutylene? How to make the isobutylene beta? First, iso means which carbon must have methyl group? Tell me beta.
Second.
Second carbon must have methyl group. Now iso is completed. Now butylene, the total carbons must be 4. Butylene means the total carbons must be 4. So 4 is completed. Okay, what is the meaning of iso? On second carbon put methyl group and remaining must be in straight chain. The remaining whatever must be what? In straight chain. That is compulsory. This is the rule compulsory. Iso means second carbon must be methyl group and the remaining carbons, whatever the remaining carbons are there, they must be in straight chain. Now but means here 4 carbons. Total number including this methyl also 4 actually. Ene they are saying. Ene means what actually here? We have to keep a double bond. Anywhere you can keep actually. So you can keep anywhere. So I am keeping here also. If you keep here double bond, what happen? It will become 1 actually. If you keep double bond here, this carbon will get first position. If you keep double bond here, what happen? This carbon will get here first position. Okay? Both are actually what? Same only, right? Now in this case, the nomenclature will be, this one also you remove. 2-methyl propene, right? 2-methyl propene. This is the IUPAC name actually. 2-methyl propene is the IUPAC name. Nobody will give 2-methyl propene because you can easily write no. They will give what actually? Common names for simple molecules. They don't give the common name for what having the carbon, number of carbons are having 6, 7 like that. Only up to what 4 carbons or 5 carbons. Common names only for up to 5 carbons, not more than 5 carbons. So you have to practice like this also, isobutylene. Now after doing what? H2SO4, something just imagine is a hydrolysis process. Because they given here, hydration is given. Definitely it is the hydrolysis process. So take for what? H2O in presence of H plus or dilute H2SO4. Now you write remaining hydrogens, how many are? 3. Here how many hydrogens I can kept on second hydrogen? Tell me. On second carbon, how many hydrogens I can keep?
No hydrogen.
No, very good. Because double bond carbon having 4 bonds, no need. But here I can keep how many hydrogens here?
2.
2 hydrogens here. Okay, I can put here 2 hydrogens. Now I have to follow compulsory, strictly I have to follow Markovnikov rule. Compulsory I have to follow Markovnikov rule. Now do the addition reaction now here. H plus and OH minus. Now go for Markovnikov rule. Now tell me the product. The name of the product you have to tell me.
C.
Tertiary butyl alcohol we are getting? Very good. That will be tertiary butyl alcohol. Let me see again. Now you see this one will get here hydrogen, right? This one will get hydrogen. You are getting CH3. And this part will get here OH. Now definitely this will be the tertiary because the carbon which is bonded to OH bonded to 3 carbons, isn't it? 3 carbons it is. Therefore, this one must be a tertiary. And total number of carbons are 4 butyl, tertiary butyl alcohol. For this one, IUPAC nomenclature will be 2-methyl, 2-propanol, isn't it? 2-methyl, 2-propanol. Whoever get the nomenclature, they can only solve the problems. Remaining one, even they can by heart many number of times, which has given notes, isn't it? You have watched the video or you have practiced well, what have you have not practiced, just read whatever I given. They can't do anything. Whoever practice like this by taking different number of molecules, if you practice, take different reactants, do practice. Then it will remember for a long time. It will be remembered. Up to exam also it will be remembered. You take what isopropylene, isobutylene, isopentylene. Like that you can take number of tertiary, something also you can take like that. Before that, what happened? I will write the mechanism, simple mechanism also one more time right here. One more time, one example, only one example I will take here. CH3, okay, CH3. Now, CH double bond CH2. On doing B2H6, nobody will give boration like that. Okay, hydroboration they don't give. Simply they will give in examination B2H6 First reagent followed by what actually? Hydroxide, OH minus means what actually? In presence of H2O2. Like that they will. This means what actually? NaOH or KOH. Meaning of this OH minus is what? NaOH or KOH. They are base actually, basic reaction. Basic hydrolysis also we can call. Previous one is called acidic hydrolysis. This one is called what? Basic hydrolysis. It's nothing but what a basic hydrolysis actually, right? Now tell me the name of the product, major product according to Markovnikov. Major product according to, sorry, anti-Markovnikov. Major product according to anti-Markovnikov. Now tell me the name of the product here. Tell me the name of the product. Do fast. Write on a notebook and tell me the product name.
2-methyl butanol.
2-methyl
Butanol.
2-methyl butanol.
2-methyl butriol.
3-methyl butanol.
Butanol. Very good. This is correct. Now, this I am writing what happened according to Markovnikov. According to anti-Markovnikov. Okay. According to anti-Markovnikov rule, the negative part OH minus attacks which carbon? Double bond having more number of hydrogens here. Double bond having more number of hydrogens here. So you are going to get here CH2. Here you are going to get the CH2OH. The numbering must be done from which direction here? Functional group side here. So here 1, 2, 3, 4. Therefore 3-methyl 1-butanol or 3-methyl butanol. This will be correct answer. 3-methyl 1 or butane-1-ol or 1-butanol. Isn't it? This is the way. So that is the reason what happened. You do write on notebook, then give numberings, then you will get definitely what happened, nomenclature. So now let me see now. Let me see now what happened. The remaining reactions also let me see. आपने कंप्लीट किया हैलोजन का एक्सरसाइज, पूरा एक्सरसाइज कंप्लीट किया? कुछ होमवर्क, कुछ डाउट्स हैं इस पे? Any doubts you are having in that one?
No, sir.
No, all of you complete that exercise present in the NCERT. All in text and exercise, everything you need to complete. In text questions, solved problems and exercise, everything you need to complete. Now, reduction or hydrogenation of carbonyl compounds. Next method, reduction of carbonyl compounds or hydrogenation of carbonyl compounds. Both are actually same. So I am writing here simply reduction of carbonyl compounds. Reduction of carbonyl compounds. Let me see. In this case, in the previous case, what is the reactant beta? The previous method, what is the reactant? Previous methods, what is the reactant we have taken?
Alkene.
Alkenes. Now the reaction is what? Reactant is what here? Carbonyl compounds. Nothing but I am taking here aldehydes. Now I am converting aldehydes or ketones. These I am converting into alcohols. In the previous case, previous methods, whatever we discussed here, hydration and, isn't it, hydroboration methods, these two methods are converting alkenes into alcohol. In this way, if you remember what happened, it will be useful for the conversion method. Now in the next process, carbonyl compounds are converted into alcohols. Carbonyl compounds means aldehydes or ketones collectively called as carbonyl compounds. In that, one is catalyst, the addition of catalyst and hydrogen called catalytical hydrogenation by simply adding what? Two nascent hydrogens. So both are giving what? Carbons into alcohols. Now this is the C double bond O. This group is called generally what happened? Carbonyl compound. Now converting into your alcohol. Now we get alcohols. If it is ketone, you will get definitely tertiary alcohol. This will give tertiary alcohols. Okay? Sometimes you may get what happened here aldehydes. You will get here primary alcohols. Here you may get secondary also. Okay. So definitely what happened, aldehydes will give primary, secondary, tertiary. Let me see this one. Later we can see this one. Not to avoid confusion, later this one. So in this way, carbonyl compounds are converting into alcohols. Let me see this one again. This is formaldehyde. Everyone knows this. Do you know this one? Formaldehyde. Methanol. Meth for one carbon. Meth for one carbon. Ane for what? Single bond on carbon. This you don't consider this double bond. Okay. All for what? Aldehyde. This is aldehyde group. So methanol. Now this methanol on reduction, it presents a hydrogen, nickel, palladium or platinum. You can take nickel or palladium or platinum. The reactivity increases from nickel to palladium. Temperature you are maintaining something 413 Kelvin temperature. So temperature nobody asks you. Remember, temperature nobody asks you. Simply hydrogen presence of nickel or palladium or platinum. Now what happened here? This group will convert into CH2. Primary alcohol you are getting. You are getting what actually? Primary alcohol. How we got the product? I will write here. Very simple. How we are getting the product. In all the cases you have to remember this shortcut. Now first of all, break the pi bond. First thing what you have to do? Break the pi bond actually. Now put here one hydrogen and put here one hydrogen. Finished. How many hydrogens I have taken here? 2 hydrogen. Put one hydrogen to the carbon. Put one hydrogen to the oxygen here. Now break what? Pi bond. Not all the bonds. Break the pi bond. Now you are going to get what here? CH2. Primary alcohol you are getting. Methanol you are getting. Methanol will convert into methanol. Okay. Ol for alcohol. All for what actually? Aldehyde. Okay. So this is about actually what? For methanol. Isn't it? This is what? Methanol. Primary alcohol. Isn't it? All it is. Next, if I take what? Acetaldehyde. CH3CHO. Acetaldehyde. This is the name is called acetaldehyde or ethanol. Because 2 carbons are there. Eth. Between carbon, single bond is there. Ane. And the functional group is what? Aldehyde. All it is. So 2 carbons eth. Between carbon, single bond ane, and aldehyde group is there, acetaldehyde. On doing again hydrogenation in presence of nickel or palladium or platinum you can take. Now what I have to do here? I have to break the bond. Which bond I have to break here? Which bond I have to break here? Pi bond. Now put that this hydrogen, one carbon and one oxygen. You are going to get the product. CH3CH2OH. You got again here? Primary alcohol. Here also we got primary alcohol. That means what happened? Aldehydes are giving here primary alcohol. Now do one exercise, this one. CH3CH2CHO. Try this one example with what? Hydrogenation presence of nickel. Hydrogen presence of nickel. Or do this one also. CH3CHO. Do again here also hydrogen presence of nickel. Very simple. I'm writing here CHO. A CHO or like that also you can write CHO. Now what you have to do? What you have to do? Again write down the reactant one more time. Write down the reactant one more time. CHO. This is CHO. This part is called CHO. Understood? CHO I'm writing here. Here also write down CHO only. CH3, CH, CH3, CH2, CHO. Now, how to make the product here? Now, put one carbon. For this carbon, give one hydrogen. For this oxygen, also give one hydrogen. Now, it will convert into CH2. That means CHO will convert into CH2OH. CH2O converting into CH2OH. Here also, one carbon. This carbon will get one hydrogen. And the oxygen also getting one hydrogen here. So, you are getting here also CH2OH. So, what you are observing here, CHO on reduction converting into CH2OH. You are getting primary alcohols. So simple आपको याद रखना क्या है यहाँ पर? CHO is converting into CH2OH. With this we can get n number of examples. By taking different number of reactants, you will get the different types of products here. Okay, next we will see this one, ketone amide. Now it is ketone. Term is what? Ketone. Acetone, common name is called acetone. Dimethyl ketone also common name. IUPAC name is called what? Prop. We are having 3 carbons. Ane, because carbon having single bond, and this part is what actually keto part is called what? One. Ketone. Functional group is ketone. One it is. Okay. This part you have to take. Now here what happens? Same thing you have to do. Same thing. What I said here. Break the pi bond. Break the pi bond. Put one hydrogen here. Put one hydrogen. Isn't it? Do what hydrogen presence of nickel or palladium or anything you can take here. Now put one hydrogen here, put one hydrogen, you are going to get here hydrogen and hydrogen. So here you are getting what? Secondary alcohol. Okay, you are getting what? Iso or secondary. I mean, number of times I told you iso secondary propyl alcohol. Propan 2 you are getting. Secondary alcohols you are getting. So these are also very important one. You can remember like this. With less efforts, you can remember this one easily by this mechanism. Break the pi bond. In both the cases, for aldehydes or ketones, break the pi bond, put one hydrogen here, put one hydrogen here. You will get the alcohols. If it is aldehyde, primary alcohol. If it is ketone, you are going to get secondary alcohol. The same reaction you can also do with another reagents also. Same methods we can also use by using another reagents. What are the different reagents we can take here? Sodium amalgam in presence of water, one of the reagent. Instead of hydrogen nickel, you can take this reagent, or you can take sodium boron hydrate or lithium aluminum hydrate. These are the 3 different reagents you can take. That means lithium aluminum hydrate, sodium boron hydrate, sodium amalgam in presence of water will give same effects which are given in the previous case. Okay, same thing, sodium amalgam, same. What is happened here? Break the pi bond, put hydrogen, put hydrogen. Here also CHO will convert into CH2H. Here also what happens? CHO will convert into CH2H. Okay. If you take aldehydes, what type of alcohol you are getting? Primary. If you take ketone, what you are getting here? Secondary alcohols. Understood here? Let me move to next slide now. This is only we discussed just now. Primary, secondary we can prepare. Tertiary alcohol we cannot prepare, especially by using hydrogen, but we can prepare. The different methods are there. Let me discuss that. So by using reduction method, we can prepare primary, secondary of aldehydes and ketones, isn't it? Now one more thing, if you observe lithium aluminum hydrate, which is expensive one, very expensive one. So used for preparing only for specific, isn't it? Only whenever we use only lithium aluminum case only we use actually. Okay. So generally what happen, acids are reduced into, generally what happen for carboxylic acid, this will get in the next, the carboxylic acid, the chapter called carboxylic acid will get this topic. So leave it this one. Okay. That's same thing we get here. I don't explain this one, but anyhow we get that one. Carboxylic acids, and you convert that one into lithium aluminum, we'll get that. No problem. Okay. Actually here also same method only we can do. Here one hydrogen. Here one hydrogen. Okay. Now what happened here? One hydrogen. Put like that here. Now what happened here? Water will be removed here. H2O. Water will be removed. Now here one more hydrogen. Total 4 hydrogens we can put. So this will discuss in the next carboxylic acid. We'll discuss this one. Okay. Leave it this one. This one also I will discuss in the carboxylic acid. Esterification reaction. Here I don't discuss this one. Carboxylic acids reacting with alcohol will give ester only. That also leave it this one. Now here also reduction method is what? Method is taking place here. Oxidation reduction method is taking place. Now what I have to do here? Keep one hydrogen here. Keep one hydrogen here. Okay, you will get this. This name is called cyclo because closed ring. Hex because total number of carbon 6. Ane because single bonds are there between carbon. One because it is a ketone. Now again closed one. 6 carbons are there. Between carbon, single bond is there. All because there is an alcohol. So cyclohexanol will come by cyclohexanone. So conversion of cyclohexanone into cyclohexanol by which reagent? Reduction reaction. Oxidation reverse process. We give the name for this one. The reagent used for conversion of ethanoic acid. Just now this is no need actually because we'll discuss in the later. This is also will no need actually. Grignard reagent. This is very 5-star question. It is very important one. Very important one. Grignard reagent. So by using this Grignard reagent, we can prepare all types. Primary, secondary, tertiary alcohols can be prepared by using this method. All types of alcohols can be prepared. Now, what is the name of this reaction? Nucleophilic addition reaction. Preparation of alcohols, listen carefully here. Preparation of alcohols by using what? Grignard reagent is called what? Nucleophilic addition reaction. Let me see this one here. Now, if you observe here what? If I put here hydrogen, that will be aldehyde. If I put here hydrogen, that will be aldehyde. If I put here what happened? Alkyl group, any alkyl group, that will be ketone. You know this one very well. Okay. This is on reacting with aldehyde or ketone. On reacting with Grignard reagent, you are going to get what actually here, isn't it? Alcohols. Whenever if you take what happened, Grignard reagent, you have to take what? Dry ether compulsory you need to take it. Compulsory you need to take what? Dry ether actually. So this is a mechanism, but if it looks what happened difficult for you when you see up this whatever the screen what happened, it is difficult to understand. I will make this one into very simple. To easy understand, I will make what happened very simple for you. Very, very simple for you, isn't it? So again, I will come this one, will come to this point actually. Let me see this one actually. Okay, first of all, what I do here, I will take the formaldehyde first of all. Everyone knows no formaldehyde?
Yes, sir.
Yeah, just a minute. I will take formaldehyde. H, C, double bond O, H. This is called formaldehyde. I am writing the names also once again. All of you write down this one. Within 5 minutes we can complete this today's class. Formaldehyde, Grignard reagent, RMgX. RMgX. In the place of R, I can put CS3, isn't it? I can put C2H5 like that. Okay. R means, shall I put here what? R place CS3? No problem, no? Anybody has getting problem here if I put in the case of R, CS3 or C2H5, any alkyl group I can put. Now what happens here? I told you which reaction is nucleophilic addition reaction. This reaction is called nucleophilic addition. What is nucleophile here? CS3 minus. This part is the nucleophile. CS3 minus, this part will be the positive. This nucleophile attacks here. This nucleophile attacks here. Now, because of this, carbon will get 5 bonds. No, the pi bond will be shifted over on oxygen. So we are going to get like this product. CH, here one hydrogen, same thing. Now here we are getting what actually? CH3, here it will be O minus. Now do hydrolysis. Put some H plus over here. H plus in presence of water. Add some H plus here. Add H plus here. Now what we are going to get, write down CH3. This part is CH3. Then this part is what? CH2. And this part is what here? OH. So formaldehyde is giving here primary ethyl alcohol. Primary alcohols are producing. Nothing but it is a ethyl alcohol. So formaldehyde is giving what? Primary alcohol. That is what? Ethyl alcohol or ethanol. Okay. Now in the place of this formaldehyde, if I take acetaldehyde, CS3, C, isn't it? Double bond O, H I am taking. Double bond OH. Again, Grignard reagent, RMgX. I am taking here CH3 MgBr. I am taking CH3 MgBr. Again, nucleophilic addition. Now, this part is negative part. All of you, please observe here. This part is a negative part, attacks the carbon. Now, the pi bond will shift on oxygen. Now, we are going to get CH3 CO minus. Okay, here hydrogen, and here what we get here? CS3. Now do what? Hydrolysis here. This is called hydrolysis reaction. Hydrolysis reaction. Okay. H plus and water. H plus and water. Now add H plus to where here. Now what we get? Put this right on this hydrogen CS3, CH, and here also what happens? CS3, OH. Now this is called isopropyl alcohol. Okay. Isopropyl alcohol or secondary alcohol. Secondary propyl alcohol. We got a secondary propyl alcohol or isopropyl. Now this is what? Acetaldehyde. 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 Next I will take what? One more aldehyde. CS3, CH2, CHO I am taking. Now if I take what happened again? CH3, CH2, MgBr I am taking. CH3, CH2, MgBr. Now again doing what? Nucleophilic addition. Now this part will be completely what happened? Nucleophile. This part, everything is a nucleophile. Now attacks carrier. This one, this carbon. I'm writing this one CH4 like this. You can put CH4 like this also. Okay, from CH2 side, whichever connected to magnesium. Okay, whichever connected to magnesium, this carbon you have to don't attack this carbon. Okay, attack what? Which carbon? This carbon you need to attack. Whichever directly linked with magnesium, that carbon will be attacked here. So CH3, CH2. Again, this pi bond will be shifted over here. So you are going to get CO minus. Here it will be CH2, CH3. Then what happened here? CH. Now add what happened here? H plus here. Add your H plus here. You are going to get here CH3, CH2. Next what happens? CH. Here we get here OH. And remaining will be CH2, CH3. This is also again secondary alcohol or 2 pentanol. It is 2 pentanol. So 3 pentanols. 3 pentanol it is secondary alcohol. And finally, if I take what ketones here, I am taking here what ketones? CH3, C double bond O, CH3. Do take again CH3, MgCl also we can take, MgCl. Okay, Mgi also we can take, except for remaining you can take. And again, nucleophilic addition. Now, again, this is taking place. So what we are going to get CH3CO minus, and it is CH3. And here also what happens? CH3. Add your H plus here. Add your H plus. H plus, add your H plus. CH3, CH3. You also what happens? CH3. And here you will get OH. This is called what type of alcohol? Test. Now, finally, what we get here? Ketones. All ketones will give tertiary alcohol. All aldehydes except formaldehyde, all aldehydes will give secondary alcohol, and formaldehyde only will give primary alcohol. Okay, this is the thing actually. You observe here formaldehyde. You observe here formaldehyde with grignard reagent is giving primary alcohol. Aldehyde except all aldehydes except what happened? Formaldehyde is giving secondary alcohol. And all the ketones, any ketone will give tertiary alcohol. Okay. So by using grignard reagent, we cannot prepare methanol is impossible. In this case, remember, methanol is not possible. You try this one. Methanol is not at all possible. This is very, very important. By using grignard reagent, you can't prepare methanol. Methyl alcohol cannot be prepared. Now, whenever if you prepare grignard reagent, we cannot prepare any compound which contains what? 1 carbon atom. Methanol contains how many carbons, beta? 1 carbon. So we can't prepare this. So these are the important things we need to remember. This you take a snapshot. All of you take a snapshot of this one, or you write on a notebook. So very, very important topics. Now I will give some homework for you. Homework also I will give. This is generally you can do this one. This is no problem. I have to waste the time. Do one thing actually. You have textbook with you now, beta?
Yes, sir.
Yes, sir.
All of you just open your textbook so that you can note that one. If 5 members join today. Okay, I will do one thing. I will post on WhatsApp. Okay, whatever the exercise is there, because it is already 10:40. You can leave now. So after in WhatsApp, I will post which you have to do this one. Otherwise, if you have time, you can stay with me. If you want to note down, you can stay with me, because it is not responding very well. So take some time actually. It's not closing or.